Sour cream, really? This is the flavour you like?
The flavor from hunger.
How original.
Sour cream, though?
I was actually trying to get the original flavor.
Okay.
How much was this?
I don't know.
Guys, can we look up now?
How much is this?
150.
Okay.
Looking up?
You should have said like 5 or 6.
Okay.
Hey, I have coins.
Keep your money, I don't want your money. I don't want them. My treat. Wow.
You want to treat me next time? Tell me before. That's how it works.
Okay. Guys, come on. Omar. Come on. Faisal,
Get you something.
open up your notebook and write this down.
Oh, you know what we would need for this lesson?
I know.
Do you know who has it ready? Oh, it's here. Oh my god. Oh. Look scared for a moment.
Are we ready?
Whenever you want.
I doubt that. Wong! Wong! Wong, what's wrong? Can we start?
I think I left my hand oh, no, it's here.
So if you forgot it,
Hang in there, Stephen. Only a week and a half to go. There hasn't been any murders yet.
Let's keep it that way.
we won't snitch.
I think people will notice when Wong doesn't show up for the test or something. It's like, where's Wong? I think he went back home.
In a black bag.
As I say that to myself. He went back home in the cargo hold. Okay. Too bad. Now, for this last chapter, we're looking at something called the normal distribution. And we start off by looking at what's called the standard normal distribution, which deals with a special type of number, which I can show you here. I'll just open up this program here to generate some random numbers here. But just before doing that, just to give you a kind of idea of what we're doing, can you all take out your calculators? And do you see a button on the bottom where the decimal point probably is?
Yeah.
Called rand. Yeah. If you press that.
Rand?
There's R&D.
Yeah.
Or R&D.
The decimal
there's
point
two?
is
Rand
rand.
International
There's
or
R&D.
one?
Let me see which one I want.
You want the...
Not rand with the hash, I'd say.
Not the international.
And tell me what you get.
We equal?
Yeah.
Around the number.
631 over 1000.
Yeah.
What's it again? Oh, different number.
Yes.
Whoa!
No, same.
So, this button here,
3, 2, 1.
guys,
Let's do it until we get the same number.
Booyaka, booyaka! 619! What is that?
you guys like play Xbox, don't you? So how is this as exciting? Would you get this excited about the new Call of Duty game? Like, no.
I got 0.
You?
Really?
No, you can't get to 0. It's between...
I just
Oh no,
did.
it's between -1 and 1. So
No, it's not. So the rand button on your calculator, that gives you a rand between 0 and 1. And usually in maths we represent such a number by the letter U.
Don't you told us this, but we all forgot.
That's fine. That's why I repeat myself. It's a skill I learned as a teacher. Now, this U stands for
Random.
uniform. because it can be anywhere between 0 and 1 on your calculator. And you actually use this for your assignment. You remember, so for example, if I said something like 2u plus 1, that would be a random number between what?
2 and 1 and 2.
Between 1 and 3. Because the biggest this could be is 1. And the smallest it could be is 0. So it could be between 1 and 3 then, for example. Now, this uniform button had some use for us. It let us do the integration in the coursework too. But it's not a number that models what behaves in real life. So for example, if I was to look at people's height in this room, it'd be wrong to say that people's height is like 200u, because it's not right to say that people are between 0 and 200 centimeters. Obviously, you can't be at the 0, or you could be at the 200. Yeah, well, some people could be, but you get the idea that randomness in nature doesn't happen like this. This is what you might call a very sort of artificial, synthetic computer randomness. In nature, randomness is not like this. It's not between 0 and 1 and could be anything in between. In nature, it's more like what I'm about to show you, if I can open it up here. Remind later.
I'll tell you an interesting fact. My great-grandfather was 201 centimeters. And here I am.
Not 201. True, 201?
Yeah.
Nice.
201.
But you're not short.
What?
You're not short compared to Irish people. The height is good.
Yeah, I'm like 177, 178.
It's fine, but you're thinking, could have been 200.
My father is 188.
So what's happening in each
I don't
generation?
know. I don't know what's going on.
Are your kids going to be like 160 or something?
I don't know.
Grandkids
I'm already
140?
losing my hair.
Oh dear. Right. So you can actually generate these. Let me see.
My father is big. Big daddy.
Big. You're confusing me. Hang on. Oh, what is it? I think it's. Dude, he is.
Is this a new graph thingy? No, but this is not graph. But it says plot.
Can you just be quiet for like. Forgotten F. Dang.
But you.
I'm missing the N. Right. Give me one uniform random number. I pressed it twice. Give me one. Fat fingers. Hang on.
No, I don't think it's you.
Hold on.
Yeah, because everything you wrote was repeated twice, so I think it's the program.
Okay, I can live with that.
Unless I do it and it happens once.
No.
Yes.
No.
Thank you.
Now,
One, two.
this is 100 uniform numbers between 0 and 1.
It says 96.
Yes, that one is 96, 97, 98, 99, 100.
Nice.
There is 1,000 random uniform numbers. Let's put this in a bar chart, okay? So let me just put this in a bar chart. And if you were to picture counting these up and put them in a bar chart, what shape would the bar chart be?
Bell shape.
No? What shape? No?
Straight line?
No, it's like
It'd be flat, yeah.
how? See?
So for example, if you look at how many numbers you have between 0 and 0.1, we have about 100 of them. Between, for example, 0.2 and 0.3, we have about 100. Now, it's random, so it's not going to be exactly the same for each interval, but if I generate more, for example, here are 10,000 random numbers on a graph. You see, it's flattening out a bit more. If I do 100,000,
But then the difference is still big, but it's still bigger.
Yeah.
Zero. Another one. You repeated the same one.
no, there we go. Will we one more zero? No, hang on, we're pushing the limits here.
Nine.
So how many have I got here now?
Go for
1, 2, 3, 4, 5,
10
6.
million.
A million random uniform numbers.
There's 10 million.
Calculating.
Keep going until it lags.
9. Go for 9.
10 million.
10 million, is it? Alright.
9.
Hold on, give it a sec now. It's getting there.
I dare your laptop to calculate a trillion.
It's struggling with 10 million. There we go. Nice. So this is the graph for a uniform, but this is not what you get in nature. So what do you get in nature?
What's E?
Oh, that means that's short for 10 to the power 7.
Oh, the button that I use that you hate.
Correct.
See, smart. The calculator.
Yeah, no, you're right. That's true. Whatever you say. Now, this is the type of number that you would get in nature. Now, so far it looks like the same, so let's generate many of them. Here's 100. This is more realistic to what happens in nature. So you notice some of them are positive, some of them are negative, most of them are small, some of them go up to 1, 2 or 3. And to help you picture this, let's make a graph of it, and let's make 10,000 of these numbers.
These notes. Ha! Got it.
Please be quiet. This is more realistic to what you get in nature. When you think about people's heights, some people are tall, but not many people are tall. Some people are short, not many people are short. But most people are in the middle. Yeah. Yeah, you're probably somewhere to the higher end for a Chinese student, right? Right? Yeah. Stop. What? Stop. Hang on. Look, I can be a racist by myself, okay? I don't need your help. And I wasn't being a racist, that's me. Okay, so this is what happens in nature. You have your random numbers spread out more like this.
You know, see the -4? You're after it.
Faisal, don't be ridiculous. It's the -5, which is not so these are called normally distributed numbers, or what I call the lesson standard normal numbers here. And the letter we use for this is the letter Z. And this is what we call the standard. I know it's loading. Normal. So if you look at the graph, most values are between what two numbers?
-4 and 4.
Yeah, in this graph it's between -4 and 4, but you don't have much between -4 and 4. Like really at -2 and +2, you have most of them. Now, of course, there is more than that. So what you could say is mostly Z will be between -2 and 2. But of course, there are values outside of this.
Is that for this specific example? Or?
No, for Z, the standard Z, not just this particular one here. Yeah? Okay, so you get the idea with this now. Your calculator does not have this button, so it cannot generate numbers like this. But the reason this is important for you in engineering... Shut the door.
Come in.
Hey, who are you looking for, me or them?
Them actually.
Okay.
Did I give anybody here any written feedback this morning on the chemistry essay?
No, the science group got.
Yeah. Okay. That's fine. I just wanted to collect up written stuff to photocopy it, which I'm doing with the other lads. And I'll be with you because you're waiting on stuff from me. You're waiting on stuff from me. And that's it, I think, here, isn't it? So I'll send that to you today. Okay?
Grand.
You're
Okay.
welcome.
As I was saying, so mostly, but not all of them, are between -2 and 2. Now, this is useful because in engineering, you'll see this shape of graph a lot. For example, if you were building, let's say, if you were measuring the strength of something and you were measuring how many newtons you need to break it, and you do this experiment many times, so this is the frequency and this is the force in newtons, and let's say this could be kilonewtons. So let's say this could be 1, 2, 3, 4. So maybe sometimes it requires 1 to 2 kilonewtons. Sometimes it's 3 to 4. 2 to 3. Most of the time is 3 to 4, and then so on. Like most things in nature follow this bell shape, where you have a lot in the middle and not many at the end. And think about this, it makes sense. That's how we see things. So how is this useful for us? Well, when you have these graphs I just showed you, they're called distribution graphs. Woo. And here is usually the x, and here is usually the frequency. If you want to know how many will I have between, let's say, A and B, all you need to do is calculate the area of this graph. So if we think about our uniform, for example, what's the smallest our U could be? 0. And the biggest? 1. And the graph looks like this. And usually we put a scale on the axis so that the area can give us the probability. So for example here, this would be 1 as well. Let's test this out. So if I want a number between 0 and 0.5, what's this area? Yeah, so half the numbers between 0 and 0.5. Makes sense. If I want the number between 0 and 1, what area is this? 1. So that means all the numbers are between 0 and 1. And finally, if I wanted to say between 0.5 and 0.6, how many numbers, what percent? A tenth, 0.1 of the numbers. That's fine for a uniform, but if you had this graph, where this is -2 and this is 2, and this is x, and we want to know something like what is the probability it'll be between, say, 0.1 and 0.2, we need this area. So we need to calculate this area. Okay? How could we do that in maths? Integration. What is the shape of this curve? Does anyone know? The function, I should say. Not an x squared, because an x squared will continue down like this. Not a 1 over x squared.
No.
It should remind you of something you plotted recently in the coursework.
Yeah.
The shape of this graph is the same as the shape of your coursework graph. What was the function for that graph?
Could be exponential.
Yeah, but it's a special type of exponential. No.
Exponential with a fraction power.
The fraction power is not the problem.
Negative.
No, that's not the problem. The square was. Can you integrate this? Exactly. No. No, you can integrate this exactly.
You can just put it on board.
قلت بالله العظيم مش عاوز.
Huh?
علي الطلاق مش
Hey.
حاوز.
Here's the thing, I don't even know what he's saying.
Yeah, but it doesn't sound friendly, whatever it is. So,
Force
from
feeding
you,
me.
huh?
He's force feeding me.
That would be the easiest thing, yes. Now, you remember from the coursework, you could not integrate this, so you had to use a numerical method like Simpson or trapezium. And this
Or
is
a
unfortunate. Or triangle, yes. This is unfortunate. So it means that we have no way to find the area exactly. However, all these areas have been calculated and put into a table for you already. So you could actually look this up in a table. So I'll explain how the table works. The way the table works is, you look up a number on the x, you look up an x, And the table gives you the area to the left of this. So for example, if this was, let's say, 0.1, you could look up 0.1. Now you might say, well, I don't want 0.1. I want maybe between 0.1 and 0.2.
I got you.
You could minus the two answers. If you minus the two answers...
0.0395.
Super. You minus the two answers and you get this. So the symbol we use when we look it up in the table is this symbol. That's right. The Green Lantern symbol. Yeah, correct. Also known as phi.
Never seen this.
What? You don't know who Green Lantern is?
This symbol, I've never seen it.
Seen it on Clubhouse.
And this
The same
topic,
symbol.
I mean.
So, if you want to get this area, you could look up the table at point 2 minus point 1. I want to give you some useful results that will help you out here. So you probably want to write these down. So the first one, if you need it between A and B. So if you want the area between A and B, that's just going to be phi B minus phi A. But there's a problem if you want to look up a negative value. Because in the table book, there are no negative values. So how can you look up a negative value? Well, you realize that this value is the same as this one on the right. But if you look up A, what do you get? This area. And you want this one.
This minus 1.
1 minus this, yeah. So the other useful result is when you want to look up negative numbers, it's just 1 minus the non-negative number. So that's one useful result. Second useful result. And the third one, if you need the area to the right. So for example, if you want to look to the right instead of to the left,
You do 2.
you do 1 minus.
Yeah, the
That's
step 2.
Step 2 again, yeah.
So it's the same as the one above it.
Yep. Yep.
What's the value of phi?
You have to look it up in the table book, which I'll show you how to do now. Let me this Chinese dude that logs in, I get all his YouTube notifications.
His name's Simon.
Is it?
Mm-hmm.
Been reading his mail?
No, he's a friend.
Alright, okay.
Been sending emails from his mail?
Hmm?
If he's a friend, have you been sending emails from his mail? You know you can't log in with the student account over here? So I don't know how he logs in.
What do you mean, what does he do?
He's got mad skills.
What does Simon study?
3 masters.
For what?
Accounting.
What's the password for a lecturer?
I'll tell you after class,
Okay.
if you're good.
Okay.
Now, let's have a look at an example. Can I scroll down a little bit?
No.
Oh, not yet? Okay. So what I'll do...
So these values are for the table of U.
No, for Z. We've forgotten about U completely. I just used U as a lead-in for Z.
What's the Z then?
What we've been doing in the last 10 minutes.
The area of the...
Z is the random variable that behaves more naturally.
So what if we get like a different type of graph?
I know, that's the next lesson.
No,
So-
this is standard, normal.
We're just looking at a standard situation where the Z is between -2 and 2.
So it's from A to B, and then A.
What do you
A
ask me?
minus A.
What's your question?
Oh, what's the third one?
Oh, if you want the area to the right of A, it's 1 minus the table book
From
value.
A to B.
A to infinity, technically, like this. Yeah.
And from the one minus A, it's minus A to infinity.
Say again?
The
Oh,
A
this one here?
Definitely.
Yeah, to minus infinity, yeah. Okay. Now, this is the unfortunate thing, because I'm skipping the statistics, because it's not on the syllabus, and it's not in the exam, but I like to do it to help you with this topic, but I'm not going to save time. I need to calculate the mean. Does anyone know what the mean is? The average. And how do you calculate the average? Yeah. So, let me make some more random numbers. Let me just call this data.
Standard deviation.
We'll get to that in a sec. Data. Here are my 10,000 random numbers. Let me get the average. What do you think the average might be of these 10,000 numbers?
The one in the middle.
Could you just give me a number, please?
1,
5.
What are the values from what to what?
You,
Because you have negative 7.
0.
I told you that they're mostly between -2 and 2. You're not listening to me.
and 0.
Thank you. 0. So you can see the answer is quite small. It is nearly 0. Yeah, so the average of these Z numbers is 0. Which makes sense, because some of them are big, some of them are negative. So when you average, you get 0. Yeah? Yeah. Now, do you remember calculating the uncertainty in your physics coursework? Yeah? Yep, in the lab. So we have something similar in maths, but we don't call it uncertainty. Does anyone know what we call it?
Error.
Not error? Not residual?
First setup.
Huh? No. Standard deviation. Yeah. Does anyone, if you look at this data, how much of a,
Difference between the biggest and the smallest.
well, that's not quite standard deviation, it's how spread out it is.
Between the average and the furthest one away.
No, that's not standard deviation. It's about 1. I can't remember the command. Standard deviation?
You just had a computer calculator.
What are you talking about? And be quiet, thank you. Oh wait, no, I know. Well, maybe it's SD. I didn't try that one yet. There we go. Standard deviation is about 1. What this means is that most of the time you are 1 unit away from the center, from 0. So for example, if I pick a number here from my list randomly, it should be on an average about 1 unit away from the center. Will it be 1 unit away all the time? No, of course not, because then it's not random. Sometimes it'll be closer to 0 and sometimes further away. But if I just randomly pick a number, so actually, you know what? Let me generate them. So let me make them one at a time. And if you can just type these in on your calculator. So what I'm going to do is I'm going to make 5 numbers, and we're going to see how far away they are from 0. All right. So let's make the first one. Now, you need to type in a fraction and put it over 5. Now, what do you type in here? No, 1.13, because we want to know how far we are from the center. We don't care about the minus. So just type in 1.133046 plus 0.5771644 plus 0.7468602 plus 1.137858. Okay, one more. Finally, 1.796342. What did you guys answer?
1.078.
1.07. So roughly 1. So on average, our numbers are 1 unit away from the center. Some of them are more than 0. Some of them are less than 0. But in total, they average a distance of 1 unit from 0. This is the standard deviation, the idea behind it. Yes? I see some people get this, some people don't, or some people aren't showing me signs that they get it or not. They're poker facing me. And some people are sleeping. Questions? Okay. Most importantly now for the exam, what do you need to do for the exam? Yeah?
This is the equivalent to uncertainty?
Yeah, because uncertainty was, on average, how wrong are you? So in the context of physics, the 0 would be the true answer, whereas in maths it's a 0. But in physics, when you're calculating the uncertainty, you're calculating, on average, how far away are you from the true answer. It's the same concept, except this is just numbers. Physics, actually, there was a story. It makes sense, or I don't know. What do you think?
But like, isn't this
What's on your
average?
mind?
Like, we're calling it standard deviation, but this is the average.
But it's not an average of the numbers, because if it was an average of the numbers, you would include the minus, and you would get a 0 as the average. So it's a type of average. Okay, clear on that now? Okay, so now most importantly is, what do we need to do for the exam? So for the exam, you need to use this table, which I'll show you here. This is the normal distribution table.
Do you want to learn this?
You're provided this, don't worry. How do I zoom in? So let me show you how it works. Suppose you want to look up the probability that your Z is, let's say there's 0, there's 0.5, and we want to know what is the probability that my Z will be smaller than, oh yeah, I'll go back. I want to know what's the probability my Z will be smaller than 0.5. So what would I need to look up in the formula book? 0.5. So let's have a look in the formula book at 0.5. So what you do, you start here and you go down to 0.5, which is here, and the answer is this. So what is the chance the Z will be smaller than 0.5? Yeah, about 69%. Now, you might be wondering, what are these for? Anyone figure it out? Yeah, so like, I mean, how do you use the top? What purpose do they have?
Do we do the standard deviation?
No?
Minus and stuff. It's already minus for you.
Oh, that would be nice, but no, it's not. They did the minus for you?
The 0 is not the value you're looking for. Like, the 0 is not the middle value.
No. Good, but no, that's the next lesson. No, that one is used if you need an extra decimal place. 0.56. So for example, you would look up 0.56. So you would go to 0.5, and to get the extra decimal point, you would go to here. 0.7123. So that means 71% of these numbers are smaller than 0.56. Let's test that out. Can I go back to the program? Okay. So let's say I make 1,000 of the Well, yeah, maybe you want to write the exact number down. 0.7123. Okay. So if I make 10,000 of these numbers, how many of them will be smaller than 0.56?
No,
How many numbers?
7,000.
7,123. If I make 10,000 of these numbers, 7,123 of them should be smaller than 0.56. Let's test that out. I'll make some data. 10,000. Okay. Now our job now is we need to go through these and count how many of them are smaller than 0.56. Let's begin. This will take a while. Of course, that's not how we're really going to do it because there's so many here, but we'll have the program check. So I'll just go data. Oh, how do I do this now? Data less than 0.56. Wasn't it? Sorry, what was it? Yeah, 0.56. Oh, but that's the answer. That's yeah. Yes, I have 7,031 numbers in my data that is less than 0.56. How many did I predict there would be? Not bad. Not bad. By the way, if I have 10,000 numbers, how many of them will be less than 0?
Half.
Half of them. So if I have 10,000 numbers,
5,000.
5,000. Let's see. 4,935 of my numbers are less than 0.
Why are you reading the 35?
Oh yeah, this what it's saying is this number is the 400,933rd number. This is the 34th and this is the 35th number. Yeah. Do you understand how these? Do you have a better feeling for how these Z numbers operate? Yeah. And lastly, we don't need to use the table book here. I said most of my numbers will be between -2 and 2. So let's see how many of my 10,000 numbers are less than 2.
0.1.
Should be close, but not exactly. 9,745. But if I increase it, how many are less than 3? This will be obviously more. 9,979.
But then, didn't you say all the numbers are between?
No, no. For the 10th time, I said mostly between. Not all of them. Mostly.
This one is what?
4. Getting closer.
That's it.
No, because I have 10. Oh wait, is it?
Yeah.
No, no. This is 9,999, isn't it?
Oh.
Yeah. So there's one stray little number that's let's see who he is. He has 4.22. That happened once in 10,000. So this is like your grandfather, the once in every so often.
Or maybe he's the.
No, maybe it's
Or he could be on the other side of the curve. Correct. Okay, so for the exam you need to practice using the tables. Let's have a look here.
Mr. Steven.
Yes. What?
It's too hot.
No.
They stop in my stuff.
I haven't even thought about starting it. No, that's not true. Today I thought about starting it, but then I had so many visits from students I couldn't.
And teachers.
And and principals. Different.
Only one.
Be listening. Can you try these?
She only
for a
got
few minutes?
this 3 years ago. Acting almighty and stuff.
What's your excuse? You've only been here like 6 months. Right. This is what you get in the exam, and it's in section A and B. Really, all we're doing in the first lesson today is practice using this table book, which is on Moodle. If you're looking for it, it's in the formula book here, which you'll get in the exam. booklet, Mr. Frenchman.
No, a booklet is smaller than a book. Not French and English.
Booklet, not a French word.
But booklet in English it means
Smaller than a book, yes, I know this. Yes.
10 pages.
I don't know what to say to you anymore except to start these questions. Can I close this? Yeah.